I'm going to talk about 5 steps to determine this model selection process. Now, we are doing this prediction for the combined cycle power plant with 3 subsystems, and the data set has 4 features associated with this system. So with the known frame of the features, and also we are going to predict the numerical value. So we are going to use a supervised machine learning model. Now, about selecting the features, we plug in each features into regression analysis. So by looking at the result for each feature analysis, we find out that the T temperature, also the exhaustivity vacuum has a pretty good fit with this entire observation. So they are going to include it into this regression model will be a good fit. However, the AP and the RH, 2 variables, turned out not as a good fit as the previous VMT. However, we are going to select an algorithm using the multilinear regressions. And we anticipate a high interpretability and also the accuracy, and also its effective computational resource usage to get the output. And we only thinking the single layer because we already see some good fit in those features. And just in case if the single layer model doesn't fit well, then we consider going to the multi-layers. But in this case, we are going to design 4 models. Model 1 with high correlated with the entire observation data set with the variable T and V. And the model 2, we will add AP into model 1. And then model 3, we will take a model 2 variables and swap out AP and replace with RH. Model 4, we use the all 4 features. Now, because 4 different models, so we have designed 4-fold iterations with each set contains training and validation for the first 4, and then the final set testing data set is with a total percent of the total observations. So this is a design of no replacement data strategy. And then we run through this each iteration with a different model, with a different set of data, of the training data and validation data. So this is the strategy we're going in. Now, go through the validation, and then we come out this each model's result. And as you can see, the purple ones, the R squares for model 1, and the R square for model 2, R squares for model 4, and then R square for model 3. And then and we also look into these standard errors for each models, and then we use the validation data set to run through the standard, run through the projected model, and with the standard value, standard error calculated and put it side by side. As you can see, all models from model 1, 2, 3, and 4, they all pretty good fit into the models through the validation data sets. So, seeing that the model 3 has the best R2 squares value and also has the lowest standard error. So we pick the model 3 out of this 4 model we designed. Now, lastly, we use the test set data to verify the last model we have. As you can see here, the standard error for the test set come out is a 4.6782, which pretty good fit into this model 3 standard error. They are within about 2% of the errors. So the model 3 will be the one model we pick. And that says this temperature exhausted vacuum and relative humidity has a good models to predict the electricity generated output. So this is my study, and please help me give me some feedback. Thank you.